Welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello, all. Welcome to episode 11 of Firecode Tech, the Solocast. In this episode, we are doing the introduction to fire science. Yes, this is an homage to fire on the day after the 4th of July, July 5th, and I thought what better way to touch on some of the recent events, fire statistics, fire phenomenon, fire behavior, types of fire, and it's something that is on people's mind this time of year. So I thought, why not touch on this subject a little bit more and explore one of the tenets of fire protection engineering and anybody who performs fire and life safety risk analysis, which is understanding the physics and implications of fire. I'd like to start with the definition of fire. Fire is described as by the Oxford Dictionary as combustion or burning in which substances combine chemically with oxygen from the air and typically give out bright light, heat, and smoke. So there's a couple telling pieces of this definition. It says generally combined with oxygen, substances that generally combine with oxygen. So there are other oxidizers than oxygen, but oxygen is probably the most common. And so, oxidizer is a physical hazard of chemicals. So, it's pure oxygen is an oxidizer. There are also solid oxidizers. Jet propulsion often uses solid oxidizers. And so the fuel needs a way to oxidize, and fire itself is an oxidation reduction reaction. It's an exothermic reaction. So, for those who may not know, an exothermic reaction is a chemical reaction that gives off heat as a byproduct of the chemical reaction. When giving a preliminary talk about the phenomenon of fire, it's very typical to speak about the fire tetrahedron. And in this tetrahedron, you can find fuel, oxygen, heat, and an uninhibited chemical reaction. These are the components that are needed to sustain combustion or create a fire. And the components of this fire tetrahedron give an insight into how to eliminate or suppress a fire. So when we look at fire suppressants, we may evaluate the way in which or the function of the fire tetrahedron in which we are limiting or reducing. So if we take a look at water and how water is a very good firefighting substance, let's evaluate it in the light of the fire tetrahedron. Water is a very effective cooling agent, so it takes impact to the heat portion of the fire tetrahedron in that it has a very high latent heat of evaporation. And so it can absorb a large volume of energy in its phase change from liquid to a gaseous phase. Water has a very high expansion ratio of over 1 to 1,600 times. 1 gallon of water converts to approximately 200 plus cubic feet of steam. Another big pro of water is that it's very readily available and cheap and not harmful to the inhabitants of a building. But that's a little bit off the subject. There are four main types of fire, the main types being a diffuse flame, like a candle, a premixed flame, like a Bunsen burner or a jet engine, a smoldering fire. You can think of coal, any fire that might be deep-seated in maybe charred wood or maybe like hay. And then there is spontaneous combustion. One of the common references to spontaneous combustion might be linseed oil soaked rags for deck staining or oil soaked rags from a restaurant. The process of fire is a gaseous phenomenon. There is a certain breaking down of solids and liquids or transformation into the gaseous phase, and this decomposition is commonly referred to as pyrolysis. Fire science is a combination of fluid dynamics, heat transfer, and a mixture of other physical sciences that are sort of the composition of the physics, chemistry, and engineering sciences around heat transfer and the motion of the particles involved with fire. One of the most famous introductory conversations about and lectures about fire science is conducted by Michael Faraday, or should I say was conducted by Michael Faraday, and it still offers great insight into the behavior of fire, and that is his candle lecture that he would give every Christmas. Michael Faraday would use the diffuse flame of a candle to illustrate different components of a flame and of fire. There are a bunch of great reenactments of Michael Faraday's talk on his candle lecture, and so I'll throw some links down in the comments if you want to go check that out. There are a couple main types of heat transfer. There is convection, which is heat transfer through the motion of fluids. There is conduction, which is the heat transfer between two solids. And then there is radiation, which is the energy emitted by matter in the form of electromagnetic waves. Let's talk about flashpoint. Flashpoint is the lowest temperature at which vapors will ignite, given an ignition source. So we talked about this before when we evaluated hazardous materials, but typically flashpoint is in reference to a liquid and the volatilized gases off of a liquid and when they will ignite. So this is an important term for fire science because of the gaseous phenomena of fire. And so when we look at the material physical science of different substances, flashpoint is a common metric for evaluating hazard and risk. Another good definition in discussing fire science is autoignition temperature, which is described as the lowest temperature at which a mixture of fuel and an oxidizer can propagate a flame with no other heating. Substance, this is the description of like if you had a material in an oven, at what temperature would it automatically ignite. So that's another temperature to describe the physical chemistry of the ignition of a substance. Temperatures for fire can range from about 400 degrees to about 9,000 degrees Fahrenheit, or For our metric friends, 200 degrees Celsius to about 5,000 degrees Celsius. Another good topic for understanding fire is that there needs to be a proper fuel to air ratio in order for burning to occur, or a flame to propagate, or an explosion to propagate. So a mixture can be too rich or too lean. If a mixture is too rich, the flame cannot start just as well as if there is not enough fuel, then the mixture cannot ignite. So depending on the fuel, there is a range of flammability, and depending on the fuel, there could be also a range of explosibility. Fire is a process that yields carbonaceous particles and carbon dioxide. The main source of deaths from fires generally are from inhalation, I think by over 70%. It's usually not the heat, it's the uh, poisonous ingestion of and asphyxiation due to the inhalation of carbonaceous particles. Common poisonous combustion gases are carbon monoxide, carbon dioxide, and hydrogen cyanide. Carbon monoxide is the leading killer in these narcotic combustion gases. When the body inhales carbon monoxide, it makes carboxyhemoglobin in the blood, which prevents the cells from oxygenating. Flashover is a term that describes the fire's progression into a full room event, where the smoke layer has reached a significant temperature to engulf the entire contents of a room. There are some really interesting videos of Flashover on YouTube. Maybe I'll post one in there if you want to check it out. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.